Okay, so this is a quick video on a bit of organic chemistry to do with homologous series and alcohols in particular. So, a homologous series is a family of compounds with the same functional group. So in this case we're looking at alcohols. So, by naming them, we do, if it's got one carbon, it's a meth. If it's got two, it's eth. 3, prop. 4, bute. 5, pent. 6, hex. 7, hept. 8, oct. 9, non. And 10, dec. So, if I give you an example of an alcohol, we'll use them in order. So meth, so it would be methanol. This would be C with 3 H bonds, and then the fourth bond would be the OH, which would make it an alcohol. Then ethanol, which, if you see up here, has 2 carbons, would be carbon to carbon bond with 3 hydrogen atoms around the first carbon, and then on the second carbon we'd have 2 hydrogens and an OH bond on the second one there. And my third example, propanol, you can clearly see this has 3 carbons, like it says up there. The first has 3 hydrogens, the second has 2 hydrogens, the third has 2 hydrogens, and an OH bond. Now with alcohols, you can have 3 different types of alcohols. You can have primary alcohols, secondary alcohols, and tertiary alcohols. But we won't look at the tertiary for the moment, we'll look at primary and secondary. So primary alcohols would be, for example, we'll use ethanol in this case. Primary would be when it's on the end of the carbon, which it would be in both cases because each carbon can be seen as carbon 1, so this would be a primary. A secondary, on the other hand, would be if you've got something like propanol. If we draw this out with all its bonds, you'd have the OH group on the second carbon rather than the first. So then you could label the carbons carbon 1, carbon 2 and carbon 3, or carbon 1, carbon 2, carbon 3. It doesn't really matter as long as the OH group is on the second carbon. And primary and secondary alcohols, they have different properties when it comes to reacting, which I'll do a further video about. So, the actual general formula for an alcohol. So if we work it out, we can see there's 2 carbons on this one, for example, so we can put CN, N being whichever number, in this case it would be 2, and then we've got 1, 2, 3, 4, 5, so because that would be 2, you'd have H would be 2N, which would be 4, but you also plus 1, and then an OH on the end, which this rule works for any alcohol. So for example, let's do butanol. Right, bute has 4 carbons, so it would be C4. H2N, okay, so it's going to have H2N would be 8, plus 1, 9, and an OH. If we just confirm this by drawing it out, 1, 2, 3, 4, putting all the bonds on. It doesn't matter really where you put the OH, but I'll pop it on the end. When we've added all the carbons and the hydrogens, we can add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then an OH group on the end. Okay, I hope that helps.